Namaskar everyone. In this soil science part 2 lecture, the topic we will discuss today is mineral. First of all, we have to remember what are the point of the mineral. First point is the minerals are homogeneous in nature. The second point is that those are inorganic. Third point is that the atoms of this mineral are regularly and orderly arranged. They are regularly and orderly arranged. And that's why this mineral has some specific geometric structure. Okay, and if anything has some geometric structure, that means there is some specific constituent. Okay, so that mineral has the definite chemical constituent, and that's why they have this they have this geometric structure. So this 1 2 3 4, this 4 point if present in anything, that means those are called as the mineral. These are the 4 important point, and we all know that some important example of this mineral is that the feldspar, quartz, mica, gypsum. These are some important we all know these examples. After this, we will look after the classification of the mineral. Now if we look after the mineral classification, there will be 3 important classification. First one is the primary mineral, then secondary mineral, the third is the essential mineral, the last and least is the accessory mineral. This, and we all know that mineral actually makes the soil. The soil is made from the mineral, right? But the main part of the mineral which actually form the soil is actually the primary mineral. These primary minerals are the chief constituent of a soil. These play important role in the formation of rock, and from there this rock will be withered and will form the soil. Then secondary mineral plays another role. So we can write that the primary mineral are the chief constituent of rock. Secondary minerals are actually the changed form of the primary mineral. The main important point we have to remember that the example of these primary, secondary, essential and accessory mineral, the example of the primary minerals are, as we have told, that these are feldspar, quartz, mica, and example of the secondary mineral are these gypsum, calcite. Important point regarding this secondary mineral is that secondary mineral has the more surface area. If the more surface area, they can hold more water. That means they have more water holding capacity. Essential minerals are those minerals to form a rock. Those must be present. Those must be present in a rock. If we create a rock, primary minerals like feldspar, quartz are also called as the essential minerals. And the opposite is that accessory mineral. Those are accessory. That means they are not much needed. But example of this accessory mineral are this magnetite, tourmaline. These are some important examples. Now the important point we have to remember that this primary and secondary mineral are those examples and those formulas of those examples. Name and the formulas are very much important regarding this example of the primary and secondary mineral. I have already made a detailed chart of this name and formulation, this formula, and I don't think that creating this list again in this board is much more beneficial for you. Rather than if you get this list, you will obviously remember this. Okay, so I am going to send this list in my Telegram or in image format. I will paste the link in the description box. You can find just download it and make your own list according to your capacity, according to your memorizing capacity. Important point is that this mineral actually form the rock, right? And from this rock, when withering happens, those will create the soil, and in that soil nutrient will be present. That means this nutrient must be present in the rock also. That means the nutrient of the soil actually coming from the minerals. For understanding, I am mentioning a example, gypsum. What is the chemical formula of gypsum? CaSO4 2H2O. So you can see here the calcium and sulfur. That means the soil having the calcium and sulfur may come from this source, this gypsum. P, K, iron, magnesium, zinc, manganese, these are come from some specific minerals, right? That's why we have to remember that those chart in chart format from have made a chart regarding this nutrient and their sources. I will paste again the link of this image in my description box. Mention the name from where nitrogen is nitrogen we are getting nitrogen, from where carbon is getting. See the red and important notation, those are most important. You have to memorize at least this. So basically we are clearing concepts here. The concepts should be cleared here in this video, but those memorizing things like those names and formulas, those should be remembered in daily to daily basis. As we are mentioning the mineral in this lecture, that means we have to remember the top 3 mineral which are actually present in the earth. Now first of all, we will discuss about the feldspar. This is another important mineral, and we have to remember just 3 points regarding this feldspar. The first important point we have to remember is that the chemical formulation. See, the memorizing of the chemical formula is challenging, I know, because we have to remember so many things in the agriculture, but the tricks you have to follow, that you make some story out of these complex things. What is the chemical formulation is that the K2O Al O3 6Si O2. This is the chemical formula, right? Now how I have remembered this? I am just day-to-day basis. I am just reading. No, there are some tricks regarding this remembering of these things. I have just break down into some small pieces and make a story. Maybe you will not understand that story because my language, I am Bengali, so my language will be different. The total mineral present in the earth crust, 40% are just this feldspar. Okay, and these feldspar are easily withered. Withering, we know what is the meaning of the withering. You can check my other lectures, but it is easy to withering. That means it can be easily broke down by some biotic or abiotic factors. Now when hydrolysis of feldspar happen, hydrolysis means just adding of water, and when adding of water will occur, when rain will occur in this over these minerals, those will be withered and those will be broken down to small parts, and from there they will lead to the formation of the soil. And on the hydrolysis of this feldspar, the clay soil is generally formed. So these 3 are most important points regarding this feldspar. Now we have to remember the classification of the feldspar. Feldspar are generally 2 types. First one is the potash type feldspar, the potash feldspar. And generally these potash feldspar are formed from the acid igneous rocks, actually found in the acid igneous rocks. We all know that what is the acid rock, basic rock. We all know that. If you don't know, please check my previous lecture. And if we look after the chemical nature of this potash feldspar, actually those feldspar actually form a group which are named as the orthoclase. Those are chemically named as the orthoclase feldspar group. And another classification is that the soda feldspar, or you can say this as the lime feldspar. And as opposite of the potash feldspar, this soda feldspar actually form the basic igneous rocks. And as mentioned that this potash feldspar form the group orthoclase. So this soda feldspar also form another group. Those are called as the plagioclase. This plagioclase feldspar are generally formed from this lime feldspar or soda feldspar. Now the second important mineral I am going to discuss about is the quartz. Quartz, another, again the 3 important points you have to remember regarding this quartz. First of all, the chemical formula. This is simple, SiO2, silicon oxide. Now the total total mineral present in the earth crust, if you consider this, quartz actually form the 36% of the total mineral present in the earth crust. Now the important point you have to remember, please do listen it carefully, that the granite is the acid rock, right? And the quartz present in this granite is the purest form of the quartz. And just opposite of this granite is the basalt. The basalt rock has the minimum percentage of the quartz. So these are the two important points. So this granite has the maximum and pure form of the quartz, and this basalt has the little amount of this quartz. So these are the three important points regarding quartz you have to remember. Now the last and most important mineral present in this is the mica. The chemical formula you have to remember about this mica, but there are two types. Before knowing of those two, we have to remember that how much percentage of crust, how much percentage of mica present in the crust. 10% of the total mineral present in the crust is the mica. Now the two type are actually the white and black type. I am writing that white and black type of the mica. Now this white type mica are actually the potash mica. Just like the feldspar, we have the potash feldspar. Here with the white mica, those are the potash mica. It is also called as the muscovite. You have to remember this. And the black type of mica are actually the magnesium type of mica. That's the magnesium mica. Now we'll look after the chemical formula of the two type of mica. The chemical formula of the white mica is the KOH whole 2 Al2. Now you can see that I am not just remembering those things. I am just remembering the story I have made and just putting that story. It's in Bengali language. The story is in Bengali language, but I am going to understand you. I am going to make you understand that if someone enters in your home and just you say that K, or in Bengali we call that K, and you generally call Kon. And then if we recognize him or her, we will tell, oh, tu hai. Oh, tu hai. So that is called in Bengali as the oh, tui. So that's why K, oh, tui. So that's calling that KOH whole 2. So this way you can make story. We don't think that there are some other ways to remember. If you have the best memorizing power, you can memorize. But we only rely on the tricks and stories. Because this is fun, and more you can utilize your brain to understand the concepts of different things. Now we'll talk about the next topic, that is the rock. Now the rock are nothing but the mixture of the two or more than two minerals. That means you at least have to have the two mineral to form a rock. More will be better. In this video I am going to talk about the rock. That means I am studying rock, right? So that the studying of the rock is actually told as the petrology. Studying of the rock is called as the petrology. Now if I look up the origin of a rock, then it will be called as the petrogenesis. The genesis means the origin. That means when we study the origin of the rock, it will be called as the petrogenesis. Now when we will study the description of a rock, the feature of the rock, how this rock is made, the chemical formulas, those will be called as the petrography. This is the knowledge regarding the features of the rock, description of the rocks. So these three terminology are confusing, but from this I think you will not confused. Now we'll look after the rocks classification. There are many classification. We will discuss everything about this. Okay. So now we will make a column of the rock. First of all, the basic classification, we all know that the igneous rock. Second is the sedimentary rock, and third is the metamorphic rock. This simple classification we will discuss now. Now there are two important classification of the igneous rock. That the first one is the plutonic rock. This plutonic rock is also called as the intrusive rock. Okay. Now after this intrusive rock, there are the second one is the volcanic rock. Volcanic rock is also called as the extrusive rock. Now, what is the meaning of this intrusive and extrusive? Now we'll discuss the difference between this volcanic and plutonic rock, and from there you will understand what is the feature of this two igneous rock. Now this is the, if we think this is a earth, in the center we all know this has the magma, right? So this magma, we all know that this is the hot and liquid. So if this happens, that somehow this magma gets cold, and if after getting cold it will be solidified. Suppose in this near this earth surface, or just in the surface, we can find the solidified cold magma, and those will be called as the intrusive or plutonic rock. There is the long process of this solidification, and then it will be found in the surface of the earth, and those will form the intrusive or plutonic rock. But opposite is the volcanic. In this plutonic rock, these rocks are not forming just like blast, okay, they are not coming with force. But in case of volcanic rock, this word is the volcano. If this is mountain and somehow there is the volcanic eruption, those lava, those magma will be forcefully come in the form of lava, then they will precipitate in the surface, and in the presence of this air they will solidify, they will get cold, and they will form this volcanic or extrusive rock, because they are coming in force. That's why those are called as the extrusive rock. As this is the outside of the surface generally, that's why they are extrusive, and they are occurring due to this volcanic eruption, that's why they are volcanic. Simple. Now what are the example of this plutonic or intrusive rock? Is the gabbro, now the granite, now the diorite. The example of these rocks are mainly main important. The concept is simple, but you have to remember these examples mainly. Now the example of this volcanic rock is that basalt, andesite, trachyte. These are important. Now another important point regarding this difference between this plutonic and volcanic rock, though those are the part of the igneous rock obviously, and in case of plutonic rock, you can see I have told that there is the long process. That means this is the slow process, and because of this slow process, the characteristics feature of this plutonic rock is that they are crystalline in nature. The volcanic eruption, volcanic rock are fast process, because they are just coming out from the earth and just getting cold in the surface in the fast process. That's why those rocks are generally glassy in nature. So now I will discuss the fundamentals of the sedimentary rock. Actually, sedimentary rock are from the igneous rock. Okay, so suppose this is an igneous rock and withering is happening in this sedimentary rock. The next class will be the regarding this withering, and because of the withering, this igneous rock will be gets into small particles. Suppose these are the small particles, and suppose the air is flowing, and because of the air flow, these particles will just jump here, and then again because of the air or water, they will jump from here to here. So this jumping process will be continued. And this jumping process is actually called as the saltation. Okay, so after the specific period, if this particles here gets cemented, suppose this gets cemented, that means they get cemented, solidified, and those will form the sedimentary rock. So this is the fundamental story. From withering to saltation and then cementation will lead to formation of the sedimentation rock from the igneous rock. Now some important example of this sedimentary rock is that the sandstone, this limestone, and shale, this conglomerate. These are the some important point regarding important example of the sedimentary rock. Now we'll talk about the metamorphic rock. This metamorphic actually because of the metamorphosis of the igneous rock or the the sedimentary rock. So basically these are the form from the igneous and sedimentary rock. How? Suppose these igneous and sedimentary rocks got the high temperature, high pressure, high heat. This will lead the formation of the metamorphic rock from the igneous or sedimentary rock. and because of this high temperature, high humid or high heat, there is a change in the chemical structure of the sedimentary and igneous rock, and this will form the metamorphic rock. The metamorphosis creating the region of the metamorphic rock. Now the main important example regarding this metamorphic rock will be just like this: from which igneous rock this metamorphic rock is actually formed. Again, to make a chart, in the left side we will make the sedimentary or igneous rock, and then in the right side we will place the metamorphic rock name. Again, I'm going to provide the chart in my Telegram, or you can find the image in the description box. Okay, but I am mentioning some important point here, some important example here also. Now suppose this granite is what? It is the igneous rock. From granite, the metamorphic rock will be the gens. From limestone, it will be marble. Okay, so from sandstone, it will be quartzite. From shale, it will form the slate metamorphic rock. From peat, it will form the coal metamorphic rock. From basalt, the schist will form. So these are some important metamorphic rock from the igneous rock or the sedimentary rock. I will provide the chart in the Telegram or image in my description box. Okay, so just join the Telegram. You also find the daily quiz there. It will be beneficial for you. Now another interesting fact regarding this sedimentary rock is that the visual rock which you actually visualize in your daily life, if we look after the percentage or the ratio, the 4/5 will be the sedimentary rock. The rocks you are actually visualizing, the maximum are the sedimentary rock, the 4 out of 5. But these are actually volume. Out of the 5 volume, you will getting the 4 volume in the sediment as the sedimentary rock. But if you look after the constituents, how much percentage actually are forming the rock, how much percentage of the sedimentary rock actually forming the total rock you are visualizing, those will be very much less. Those are just less than 5%. So you can see the volume is big, but the constituent is quantity is the very much less. Now the second important classification of the rock is that those are in the basis of the silica percentage. Now in the left I will write the silica percentage, and on the basis of this silica percentage, the rock will be classified in the 3 classes. Now the first one will be the acid rock, and the second one will be the basic rock, and the third one is the intermediate rock. Now if you look after the silica percentage, the acid rock has the silica percentage of 68 to 70%, and the basic rock it will be the 40 to 45%, and in intermediate it is 55 to 65%. Now the most important point is that we have to remember the examples. Now we look after the example of the acid rock. Those are the like just granite we have told that, and the metamorphic rock of this granite is the gens, is also a acid rock, and third one is the sandstone and the rhyolite. These are the important example of the acid rock, and the important example of the rock basic rock is the basalt, then the limestone, then this gabbro. These are the important. And another important example of the intermediate rock is this andesite, diorite, cyanite. These are the important example, and these are the examples. But another important point we sometime ignore, but question may come from this topic, this acid and basic rock, is that now how soil is actually formed from the weathering of the rock, and the rain is an example of the weathering. That means the hydrolysis is happening in the rock, and those may lead to the formation of the soil, right? Hydrolysis means just nothing but the addition of the water. So suppose the rain is occurring in the acid rock. So when rain occurs in the acid rock, then the weathering will be there. This is weathering. Rainfall is an example of weathering. Then this will form soil, and those soil will be the sandier type of soil. Okay, but in case of basic rock, when hydrolysis or the rain will happen, the soil it will form is just like the clay type. Today in the next lecture we will discuss the withering. So just visit the playlist of the soil. You can find this lecture in English or in Hindi too. Just share this video and subscribe this channel. Thanks for watching.